Thank you very much. This is always really interesting for me because as a director of a company that deals in technology and emerging technology to satisfy client and community expectations and make our life better, I'm sometimes perplexed between how I feel about it personally, because I ingest most of the things that you do as well as trying to, as we expressed to the US EPA, and we were talking with them just a short time ago, bridge the gap between what we'd like to have in the environment and what's commercially possible. So with that as a background, let's see if I press the right button here. There we go, whoops. That'll get through it rather quickly. There we go. There's so much to talk about in this space, and there's so much involved in the technology that I'm just going to skip across a couple of areas. Happy to take questions. Happy also to provide further detail, and we've hopefully made something of a technological breakthrough at the end of this with a QR code that you can quickly come to us after that with written questions as well and seek further information. So we'll look at a little bit of the technology on how we remove PFAS from water. We'll also look at how co-contaminants make a big difference in that treatment and the robustness of it, and that is a really important part. The commercial implications, which link back to the technology, the robustness of the system, and the ancillaries that have to otherwise be attached to that treatment system. And then quickly on the environmental, and I'll try and avoid questions from Jimmy because he likes to do that to me, and how ESG is having a big part to play in what we do now for all of us. I just mentioned it, the issues of environmental versus commercial implications. And part of that, and what we talk about and what we aim to do, is achieve, I can't say net zero, even though that's the buzzword for carbon, but below levels of detection across the board. So in the minds of our clients is, do we treat to less than detectable levels? Do we treat to what's required according to our licence? What happens for a forever chemical as a residual? How does that affect our stakeholders? How does that affect our future liabilities? And in particular, how do I deal with those things now? What is the real cost implication of treating to 99% compared to 95% compared to 90%? Is my system going to generate other hazardous wastes? It's all very well treating the water in this particular fluid application we're looking at, but are we going to generate other wastes that we then have to consider? And the more remote we are, and we're a very big state, the more remote we are, the more difficult it is to deal with those other hazardous wastes. How safe is the process that I've got to treat the water, and then how do I deal with those at site in the handling, storage, transport for other wastes off-site for final treatment. Thermal oxidation as a process is widely used throughout the US. That's a problem for us here in Western Australia because there's only 2 places in Australia that are licensed for thermal oxidation, and they're in Melbourne. So if you're in the far northwest of Western Australia, at a mine site or an oil and gas installation, thermal oxidation at the moment is not a possibility. And then the importance of the other contaminants that are in the water and how that affects the robustness of the treatment system. And principally, most systems around the world rely on either GAC, granular activated carbon, or ion exchange. They're the principal. And they've been wheeled off the shelf, and they are very good at what they do. And I have carbon systems, my own water treatment for drinking water at home. But is that the best application and use of that type of media for what we seek to do? As briefly mentioned before by David, PFAS is an organic. It's a synthetic organic. It doesn't occur naturally in the environment. So wherever we find it, we've made it, and we've made it since about 1930, deposited it there somewhere. And that leads to a whole host of issues with waste. The important thing about it being an organic and being a synthetic organic is that MySelects, the product that we use for the removal of PFAS, has a very high affinity for the removal of it. History of development, I won't linger on this, but we've been doing this sort of work since 2004 around fire training grounds. We're now working with some of the majors in the area of water treatment, majors clients, both oil and gas and mining. And we're taking this work that we've done to the US. And very interestingly, in our discussions, which have been ongoing for about 12 months with the US EPA, we now have trial equipment over there. Their first question to us at the end of our first webinar with representatives from across the US, we had about 40 people in on the webinar from the regulator. Their first question was, what footprint do you need to treat 110 million gallons of water per day? They are very much on treating drinking water. That is their real driver. Very quickly, and I've got this image up there for a couple of reasons. One is to talk about the footprint. The other one is to talk about essentially the two stages of the way this technology is applied in the field. And it's important to understand it because it has a very big bearing upon the operational costs and the waste implications for the treatment of the water. So the process is one where we take water sequentially through a range of cartridge filters, primarily to remove and homogenise the water, and we remove co-contaminants, because generally where PFAS has been used in a lot of applications, you'll find other organics in the water. We want to remove those. And that's the stainless steel housings that you can see in the front and centre of the screen. The polishing element is what sits behind it. Now, the important part about all of that is, in order to treat 500,000 litres of water per day, we need something of the size of two 20-foot containers. The other important thing about that is whether it's a high level of PFAS in the water, measured in thousands of micrograms, or low levels of PFAS in the water, or importantly, a fluctuation of that, it doesn't matter. The pre-treatment in the first container through the cartridge filters actually removes the high levels. We'll get into that later. Importantly, what ends up in the polishing system is very low levels, which enables us to have very long service life. That becomes very important because when you begin to break up the actual activity and see the reductions that are occurring, and there's another detailed slide further on if we want to look at the actual components that are involved in the PFAS, but concentrating on the green line, on a general scale, most of the work is done with the cartridge filters. Now, the one thing about the MySelect's cartridge filters is they're hydrophobic. They have a high affinity for organics, so they bond chemically the organics, synthetic or otherwise, to the filters, and when you remove them, you actually end up with a dry waste. You replace those, the filters can be safely handled and stored at site and trucked as a small quantity off-site to thermal oxidation or burial at somewhere like Tallis, as is happening in some instances at the present stage. That means the polisher lasts for a long period of time. But importantly, for the ancillary works that go on around the treatment, we don't have anywhere where we've had to retreat any water. And that means we don't need to have ancillary tanks, pumps, other equipment to hold to treat for batching. It's a very, very big cost and operational change. So quickly, just to go through some of the commercial implications. So if, from the client's perspective, this is generally what they'd like to see, a low Capex, a low OPEX, and that's not only in cost of running, but the resources that are required at site and manpower, etc. A minimal waste that's safe to handle, and a high score on the ESG chart. And the possibility of being able to recycle this water as well. So I just mentioned the Capex. Well, we build these things in small containers. It's got a very small footprint for the flow that we can handle. We don't have the need for ancillary tanks, pumps, other equipment, which also lowers not only the Capex, but the carbon footprint. The systems are delivered complete to site. We really just tie in the hoses to the container and from the container for the influent and the discharge point. It's very simple. As far as the OPEX goes, and trying to keep that down to a low level, we remotely monitor our systems. We've had clients in the last 18 months that have come to us and said, we want you to provide a quote for us, which will include the on-site amenities, the ability to hold people, provide crib rooms and so forth. We said, why? And they said, well, that's what's required to run these systems. We've got a large footprint. We're putting down 1,200 square metres of concrete for tanks and everything else. We said, not necessary. We also want to have low operator involvement. So these systems are such that we have predictive analysis on when the filters will require changing. The filters account for 20 to 90%. 90% when we've got higher levels of contamination in the water, 20% when we've got lower levels of contamination in the water. The polishers have very infrequent changes. One site operating where the client has asked us to change the media, that was operating for just under 2 years before we had to change the polishing media. It wasn't spent, they just wanted it changed. The waste is the part that I think most people have overlooked, and it's very interesting when we compare our information on what we do here in Australia with what's happening in the US. In fact, we were talking just before, Australia was at the forefront of work on regulation and guidelines, and in small part, no small part thanks to Dr. Jimmy, doing his work when he was with government here in WA for setting up the guidelines. We're at the forefront, other countries were actually looking to us. Since the change of administration in the US and probably in the last throes, in the last 6 months of Donald Trump's era, they have rapidly accelerated their drive to regulate PFAS now. The interesting part of all that is the waste from PFAS in the US right at the moment is not considered hazardous. That's about to change. So the proposal of what we've taken over to the US by the service implementers has been received with open arms because of the waste issue and the ability to actually move it, treat it and discharge it at the present stage is going to change dramatically in cost. Already mentioned the remote sites and how difficult it is. On the ESG front, I guess I question why you would put in a system that only takes out selected few contaminants. We were at a conference in 2012 in Adelaide where the US EPA came and addressed the forum in Adelaide and spoke about the number of contaminants. At that stage then there was about 2,400 known PFAS contaminants. Coming into the start of 2020, that was up at around 4,700. And just as David showed before, that's now around 6,000. It's a constantly moving field. We don't know it all. A lot of IP is still restricted in its release of information. The ability to remove all those contaminants across the board can be done at very little additional cost in the operation in terms of treatment. As far as our treatment system goes, it'll take it all out. The client we're dealing with right at the present stage said, we only want to treat to 90% species protection. And we said, that's fine. They had internal talks. They came back to us and said, can you re-quote because we want you to take out to below detection. We said, that's fine. The system you've got will do that. So for us, the removal of short and long chain, or the precursors that are potentially going to lead to further liability issues in future if they remain in the water, it's a bit of a no-brainer. Take them out while you're doing it, one go. Also remove the hydrocarbons because that's an affinity for Mycelex as well. The metals will also come out and we do this all with a very low energy intensity. This is interesting. It's an interesting slide given some of the information that's contained on here. And we were talking during lunch about how to view the information we have at the moment and are we in the same position as our society was in the 60s and 70s when smoking was still seen as being a cool thing, and the nicotine companies were telling us it wasn't bad for us. There's lots of information now that's readily available on liver, kidney, testicular and ovarian cancers. There is little doubt that it's an endocrine disruptor. Further to that, cognitive and attention deficit disorders have now been linked to it through papers published in 2019, and they're available. They're on the notes there. And unlike oil, and we all get upset when we see oil discharges and losses of containment and spills that happen on the ocean, and you can see it everywhere. You can't see PFAS. And the reason we're measuring it to such low levels is because of the impact it has. It's unseen. The whole process of us putting this product into the ground or not removing it where we can now, and knowing that whatever we put into the ground is going to be there for the half-life of 40 to 90 years and continue to leach out and affect our waterways, is something that really does trouble me. The other thing that's interesting about this, and this is also in that same paper, the study points to the cost to the economy in Europe and the US, and the two numbers there of 200 billion per year and 300 billion per year are not related to human health impacts. This is losses to the economy as a result of other factors. There's just a lot to consider, and that's why I say this is quickly across the top. Look, we've got a lot more information and detail. Many of you probably haven't heard of us. We have been around, we've been doing this rather assiduously for the last 14, 15 years and really gained a significant head of steam from about 2011 onwards. We can work across the range. We'd be happy to take questions and further discussion. You can scan that and request more detail, and we'd happily provide information to you as we have done for clients across Australia. If you really want to see some more detail in terms of, this is a logarithmic scale version of what you had before with the various PFAS contaminants as done by ALS some time ago for us, so it's reliable data. If it's not, see David, he's still here. Happy to take any questions that you may have.
Does anyone have any questions? Oh, there it is, sorry.
Jimmy, I invited you not to ask questions.
No, I thought to be fair to all speakers. I'm not picking on speakers. Paul, it's quite interesting what you presented. I have spoken, have meetings a lot of your competitors, ETC2, Synergy Resources, and Pacific, OPEC. I've seen the data, I've seen the systems, I've seen the flow diagrams, and also got to know the technology. My question for you is, what is your differential? What is your value adding from them? Is it a game changer?
This is. It's actually interesting that you mentioned some of the other providers of solutions to water treatment and so forth, because of the I think there was 5 that you mentioned there, Jimmy. 4 of them have approached us for this technology to be a pre-filtration system for their polishing system, which is carbon and ion exchange. And we just simply said no. Because this system is integrated, we know it works well. So the game changer here is the energy that's required, the certainty of production, the diminishing of waste, and the extended service life, and the minimum of operational implications for a client at site. So it is a very significant game changer.
So we've got BHP. I think we've got 2 tables on BHP mining. Any questions? been a focus of PFAS in mining.
Yeah, there is. So it's interesting that having come from the oil industry and understanding, the great value that PCBs had in transformer oil, for instance, and their ability to combat thermal oxidation. One of the great things about some of the PFAS products is their thermal stability. So what makes them really good in the products that we use every day, and our inability, I think, in the short term to replace them with others that will be just as good, means that we really have to look for how we treat the byproducts of that manufacturing process, or the way that we extract oil from the ground, or the way that we pump water through a pipe. We have a lot of difficulty getting from our suppliers, the makers of valves and pipe and sealants, etc., products that are PFAS free. So every time we build a plant, we test, we do a hydro test, we fill it, we run water through it, we take samples at various points, send it to the laboratory before we can dispatch that unit off to site. Because everything has PFAS in it. If we look around here, there would not be a thing on this table, on that floor, that wouldn't have PFAS in it. The feels and textures and everything we have are all related to this one product. We can't remove them from our society. What we can do is try and keep them out of our bodies and our kids' bodies, and the animals that feed from the ground, and the water that we sprinkle on the ground, and the other products that we do. It's just mind-blowing. One of our clients had, and they took some of our systems and put them into operation, and they said, before we get involved in this PFAS space, we should, in fact, test all of our staff to see what implications this may have. We don't want to have issues for ourselves as an employer of personnel. So they did blood tests. Everybody had PFAS levels in them. So in Victoria, around Fiskville, and you've probably heard of some of the implications from press reports, the firefighters and the amount of foam, and seeing that last slide of David's with someone wading through foam. There's lots of those in history, but they have up to 2,000 micrograms per litre in their bloodstream, some of those people, and they have some other have got debilitating side effects as well that go along with it. Is it all inextricably linked? No. Have they done anything else of any particular note that would bring about those particular aspects of health problem? The jury's out on that. But yeah, I'm erring on the side of caution. Any other questions?
Oh, I do have a bit of a question.
Sorry.
Yeah. Well, no, ask the full question, not just the bit.
Where's the line?
What about insurance companies now?
Well, and look, and that's all part of this. It really
Thank
is.
you.
The insurance and the whole risk mitigation.
That's right.
Yeah, it becomes enormous. Sorry.
Sorry.
Just a pretty simple question about scalability. I mean, I guess this does about 5 litres a second, I think, if I did the maths correctly.
Yeah, somewhere between 5 and 7.
Yeah, I mean, I guess BHP up in the Pilbara, we're pumping thousands and thousands of litres a second of this stuff. Is scalability simply just adding lots and lots of these size units, or do you do much larger ones to process high volumes of water?
Yeah, we do much larger. The interesting thing is, to double the capacity of that unit, we would add one more 20-foot container as a simple. There's a multiplying effect, which is not quite exponential, but it's not linear. So the footprint increases, but the volume increases much more per footprint size of growth.
What's the largest one you've actually got running in the world at the moment?
No, it's this size. We're actually working towards the US EPA, to give you an idea, for the 110 million gallons per day, which is what's that, 500 million litres of water, roughly, just underneath that. That was 15 metres by 75 metres. And what makes that really good, and it doesn't make much of a difference to us in Western Australia because we've got so much space, But in the US, most of their water treatment facilities are landlocked. And the other thing that's really interesting about the US in their water treatment, and this is water treatment for drinking water, about 90% of the water that goes into drinking water goes through through systems. It's almost like villages, if you like, where there's less than 500 houses. It's quite extraordinary. So there's a plethora of smaller, these types of situations that they actually are interested in because they can treat their water. And they have a lot of groundwater extraction, which in some ways is similar to us here. But they have a lot of groundwater and inland waters. So they're the New Jersey, those sort of northern areas where heavy industry is, their pollution has gone into the ground. The groundwater's taken it into the river systems. Some of them have discharged into the river systems. If you've seen the movie with Mark Ruffalo, Dark Waters, worth watching, you actually see evidence of that. So they abstract from those river systems, a bit like we abstract from our aquifer, for their drinking water, treat it and then put it back into the mains potable water system.
Thanks.
What? Tell me.
That's all right.
Okay.
I may have missed the some of it when you were talking about the MyCellex product, but is that something that you've got to dispose of once it gets exhausted, or is it regenerated as well?
No, there's no regeneration. The good thing and the bad thing, if you like, depending upon which side of the fence you sit on. The great thing is MyCellex has a fixed chemistry in it. Once that chemistry has bonded to its saturation limit, it comes out, and then it needs to be principally thermally oxidised is the best way to treat it because it's just a small dry waste. The good thing about that is, unlike GAC and ion exchange, there's no steric hindrance. There's no capture and release mechanism based upon the kinetic energy of the other following contaminants that might be in the water. So once it's bonded, that's it.
I guess the second question then relates to sort of continuous monitoring of the process. Is that something that's enabled to occur, or is it you're still reliant on grab samples?
We're all reliant on grab samples for PFAS. We can infer the position of how the system is operating, and we've done that. We do that via pressure differential because we've got filters, so we're able to maintain and monitor the front end, which is key to the performance of the total system and maintaining the long service life for the second container, if you like, the polishing. And we're also able to monitor between the vessels, and that gives us predictive performance. And why we're so confident about the predictive performance on the polishing end is because we know what comes into the polishing system has been pre-filtered to pretty much a homogeneous level. So there's no spikes. We remove, the big problems with, say, carbon and ion exchange are emulsions. In any shape or form, they tend to blanket and cause early premature failure. We remove those in the front end. So it's with a very high degree of confidence that we actually operate. Okay, no more, Jimmy?
Paul, I've got a question. I'm just wondering whether you're able to share a case study where this has been integrated into the existing water treatment process. More specifically, I know your system is specifically designed for PFAS removal, so I'm wondering whether the filtration system can also treat other issues as well. So, for example, whether you can pre-dose chlorine and to get your filtration system to remove some iron and manganese as well.
The answer to the question is yes and yes. So the systems have been deployed into, because of confidentiality, I can't reveal who and where, but the systems have been deployed to operating plants now, and pretty much deployed in that sort of manner. They are able to draw from, say, a discharge sump from wherever the treatment process is occurring, and then take literally straight on and process through it. The degree to which they're able to operate across different contaminants does vary with what the contaminants are. So have we done anything with chlorine, as you suggested? No. Do we remove other contaminants with the same system? Absolutely. So out of these systems, things like aluminium and various other metals will be removed. We've also had one of our clients operate our system strictly for PFAS removal, and then they said, oh, and we have a large quantity of oily wastewater. We were thinking about using it, and now we think maybe we won't, and we've had a talk internally and we're pretty much unsure, and we said, no, that's fine. Just take the same system, pump the water through it at the same flow rate, and we'll treat the oily water. Don't pump straight oil into it, that's not what it's designed for, but oily water, no problem. Yes, Jimmy?
Can I make a comment for you?
Okay.
Yeah. I speak to a lot of other competitors. One thing I asked them, and I think I've spoken to you too, you don't want to mess around with pH. pH is, a lot of them realize it. A lot of system works very well around pH 7 to 6 to 8. You don't mess around with pH, because pH is one of the factor of solubility of PFAS and absorption on soil particles. You mess around with pH, basically the higher the pH, the more the PFAS detach the soil particles. 10 years ago, one of the way of getting rid of PFAS in soil, we talk about old contractors. The idea was a leftover from the heavy metals hit the soil with caustic soda. It's a disaster. What's happened? They detach the PFAS from the soil particles. You get more PFAS in groundwater. Last thing we have learned now. So if you mess around with your pH, you can mess around with your optimum. Okay, I thought I mentioned that. So you don't add chlorine to it. It's a no-no. Chlorine, you can reduce your pH of chlorine becomes HCl. You can reduce your pH of your system. You can get less filtration, not more filtration. I thought I mentioned that for those in the room who are not unfamiliar with PFAS treatment and absorption or the cofactors of PFAS. It's very simple. pH is one, organic matter is another one, and all the ionic exchange stuff, anions, all things that float around in your water. Those things, you get it right, you are sweet. You get a sweet cocktail. I thought I mentioned that. Don't mess around with pH, please.
Thanks, Jimmy.
Okay.
Just one more. Okay. We'll grab that time. Yeah.
Thank you. Listening to the last two talks reminded me a lot of cesium-137 concerns that were around in the 1960s. Thermonuclear testing and then later Chernobyl, of course, released a lot of cesium-137 into the atmosphere, and it was also highly known to be carcinogenic and got into the food chain and all those sorts of things. Now we don't worry about it too much because we know it's not bioavailable. It gets caught up in the soil, and I think the earlier speaker was talking about the high adsorption of PFAS onto soil. I'm just wondering whether there's something we could learn from the cesium-137 concerns of the 60s, 70s and 80s, I guess, because it's also had a half-life. It's 37 years for cesium-137, which is not that dissimilar to the half-life of PFAS. Has anyone looked at cesium-137 as a precursor, sort of learning experience as to how we deal with it?
Well, certainly we haven't, no. I guess we're working with clients at the present stage that have fire training grounds where they've now stopped either using them or have changed their fire training foam. They're wanting to put in water treatment systems because the continuous leaching of PFAS from the ground, from the concrete. So, and some of them haven't been used for 2 or 3 years. Some of them haven't been used for 2 or 3 years, but the levels of leaching are still in the order of 5 to 10 micrograms per litre in stormwater, and it seems, from their perspective anyway, that they see this continuing for the next several years. So they're mitigating their losses at the present stage. How that may relate to cesium, I'm unsure. I know that one of our close associates who we work with in development of new products and treatment systems actually was involved with Fukushima when that had its upsets, and they provided a system, media for treatment there, which was subsequently implemented. So I'm sure that there is some level of concern with cesium as well.
I guess the question wasn't whether your system could remove cesium, because it's obviously a radioisotope and things like that. The more was that there was great concern about it, but it wasn't actually being picked up a lot in plants because it was being sucked to the absorbed very strongly to the soil, and therefore it wasn't being grazed by animals. It wasn't going into the food chain. Particularly, they're worried about milk because of cesium and calcium's replaceability. So we ended up using it extensively around the world as a tracer of soil erosion, because it actually was so strongly absorbed onto soil. Wherever the area had been labelled with cesium-137, you could actually measure where the soil went to. So what I'm saying is it's the bioaccumulation side of it that I'm not sure about. If it's so strongly absorbed onto the soil, it may not get into the food chain quite as easily as everyone's worrying about, I guess. That's
sorry, that was my point of trying to address the release. So it gets absorbed onto soil, yes. It releases from soil, and that's why it moves with groundwater plumes. The Department of Defence would be the best case to point to there, and how far it's moved in Williamtown. So and likewise at Tyndall Base around Katherine, that's in the river. So they've now banned fishing for barramundi in the Katherine River as a result of what happened to Tyndall. That's kilometres and kilometres of movement in groundwater. So it doesn't just bond to the soil, it doesn't bond to the concrete. It does release, and it continues to release over a period of time. And that is the great concern. I think Department of Defence and certainly the US would not have any issue or have need to be remediating a lot of their Air Force bases. And David's slide showed if we're just talking about the US, the number of locations marked with red circles, they wouldn't be worried about it. The federal government wouldn't have paid the $360 million 18 months ago out to the claimants in the class action that were involved around Williamtown Air Base if it wasn't moving off-site and onto people's properties. It was interesting for me. My son's doing marine biology. He came home to talk to me once earlier this year about an assignment they had on PFAS in the aquatic system. It's throughout the world's ocean. So as much as we discharge to the ocean and think, oh, there's a hell of a lot of ocean out there, and 96% of the world is actually water mass rather than land mass. It's measured at between 5 and 10 picograms throughout the world's ocean. Doesn't matter where you go, it's everywhere. And again, going to that point about the period of time that it has for half-life, it is extensive. So every drop that we put out there continues to build on what's currently in our atmosphere or in our environment. I think I've spoken for long enough, I'm sure.
Thank you.